Today, we are putting its lightning-fast speed and fearless concurrency to the test by building your very first Rust WebSocket client. Let's start. We'll start with cargo.toml, a Rust package manager that defines its metadata, settings, and external dependencies. Next, we create main.rust file within source folder. In the main Rust file, we start by importing the tools we need for the WebSocket client. We use hashset from Rust's standard library to track symbols if needed. From Futures utilities, we use sync extension and stream extension to help us send and receive messages from WebSocket, and import deserialize from Serde and value from Serde JSON. Serde is what lets Rust convert JSON into proper Rust data structures. And finally, we import connect async and message from tokio-tungstenite. Tokio gives Rust an async runtime, and tungstenite handles the WebSocket connection. Rust is a strongly typed language, but before we get into data structures, let's first define our main function and the role of Tokio. Fn main defines the main starting function. Async makes the function asynchronous. Function returns almost any standard Rust error. Tokio starts its own runtime to handle socket events as WebSocket messages arrive. Connect async opens a WebSocket connection. Once the connection is established, we send the login credentials and await pauses the async task so Tokio can run other async tasks on the thread. Check out the Rust WebSocket client tutorial, link is in the description below. This starts a loop that waits for incoming WebSocket messages. Whenever a new WebSocket message comes in, Rust stores it in frame. A frame is basically one WebSocket message. In this client, it could be text data, a ping, or a close signal. Now we check the frame using match. It is similar to match case in Python. It takes the value and runs that specific block that matches it. The question mark operator means that if reading the frame failed, Rust returns the error immediately. This match operator checked two: message type text message and ping message. Text message type will include quote update subscription response or error message, which we will later parse into JSON object in next section. If the server sends a ping message, it is checking whether the connection is still alive. We reply with a pong message to keep the WebSocket connection active. After replying, we skip the rest of the loop and wait for the next message. If the server sends a close message, the WebSocket connection is ending, so we break out of the loop. For any other message type, we ignore it and wait for the next WebSocket message. In order to parse the incoming JSON messages into a Rust object, we will use Serde JSON. We will convert the raw text into a generic JSON value, which we store in V. S is a helper function to safely read text fields from V. Match S type checks the incoming WebSocket messages type value and runs the matching block. These checks are to parse control messages. If none of the matching statements checks out, we continue to the quote message type. Before we define the struct, let's check if the type message is quote data. If not, then we skip it. Here, Serde JSON takes the quote JSON value and maps it into our tick struct. If the JSON matches our tick structure, Rust gives us a parsed tick. If something goes wrong, we print the error and keep listening for the next message. The market data quoted tick messages that we receive needs to be parsed into the Rust object. In our case, we define it as tick. Deserialize lets Rust turn that data into a Rust type into our tick struct. This is similar to a data class in Python or a struct in Go. It's obvious from the struct that we are parsing strings and numbers. In Rust, however, parsing to a 64-bit floating point number type is a bit verbose. You'll notice option F64 and option string. In Rust, option means a value can be either some value or none, which is useful when parsing fields that may be missing. Now that our data model and parser are ready, all we need is to connect and subscribe. URL points to our streaming server endpoint, and the symbols array specifies exactly what we want to subscribe. We read the API key from an environment variable and send a login request. Once the server accepts and responds back with login OK, then we are ready to send the subscribe request. Similar to the login JSON we created, we send another JSON message this time to subscribe. Let's now run our program. Export your API key and run command cargo run, and voila! You can now see the live data feed directly in your terminal. Great, you have just written your first Rust WebSocket client. If you don't have an API key, head to tradermade.com and get a 7 days trial. Link for free trial below in description. Request a trial at tradermade.com and make sure to reply and send the trial coupon confirming your email. If this video helps you, make sure you click the subscribe button because we will be bringing new tutorials every week.
To watch more tutorials like this, subscribe our YouTube channel.